Hello, this is Mr. Reynolds, and today we're going to be looking at some more of the structural formula of some of the polyatomic ions that you know before. Okay, you knew these before. I think there were 22 or 23 that you had to memorize, and these were atoms that were covalently bonded. They're covalently bonded, sharing electrons, very strong bonds between them. Okay, and together they can juggle some electrons. And I said you can always look on a chart and see what the charges are. Like I know this PO4 is a phosphate group, and I know it can gain and juggle 3 electrons. Here's the arrangement. Okay, there's one phosphorus, and it's surrounded by 4 oxygens, and one of those oxygens has a double bond. And what you know from before with Bohr models, just look at these. We know each oxygen has 8 protons, 8 neutrons, 2 shells, 2 on the first shell, 6 on the second. And each oxygen wants to gain 2 electrons. So each of these oxygens needs to be bonded twice. Okay. These 3 oxygens are only bonded once. Okay, the other charge, it's going to be bonded. It's going to bond to something else, whatever else is around. And if there's nothing around, you know what? They can still gain some electrons. And when you see this sketched, a lot of times, some different places will sketch these differently, where they're basically, since they're juggling electrons, the electrons are flying around and around and around between these. And so for a while, this one has a double bond, and then it loses that, and for a while this one has a double bond, and then it loses that, and then for a while this one has a double bond and it loses it. It's kind of like, in a sense, like the juggling. If you're juggling 3 tennis balls, you actually have 2 of them in your hands and then 1 up in the air, where you can't really, you got control over it kind of, but you're not touching it. Okay, that's similar to what's going on here. Okay, by all 4 of these oxygens juggling electrons, they can gain 3. Okay, now you're not going to have to memorize that can gain 3 electrons. This 3 will always be given to you, either on a chart or whatever. What I want you to do today is, when I sketch out this PO4, you're going to be able to tell me the name is phosphate, because you can already do that. But I need you linking these 2 together. Okay, where this is a chemical formula, where it tells you what is present and how many of each. Chemical formula, what is present and how many of each. 1 phosphorus, 4 oxygens, and then this is the structural formula, the arrangement of the atoms. Okay, and since these, like I said, are polyatomic, many different atoms bonded together, really strong covalent bonds, the PO4 is going to stay together. Okay, and usually when it's written, a lot of times they'll put it in brackets. So this whole PO4 group stays together. And by, like this one, gaining by sharing, by what's called resonance, this double bond going around, by all of these sharing electrons and moving that around some, they can gain 3 electrons and get a charge. Some can gain 1, some can gain 2, some will lose 1 electron. It just depends on the atoms. So in helping you, in encouraging you to get more of a look in your head about what's going on with these, I want you getting the, I'm going to give you structural formulas today, and then you give me the correct chemical formula, and then you're going to give me the, then you're going to give me the name of it also. Okay. All right. I'm going to pause it. Okay, actually, it would be a very good idea if you got a periodic table, And if you would just pause this right now and go get a periodic table, okay? All right. So things that I'm going to give you in OneNote, you'll have an assignment to do in there. You need to listen to me talk for a few more minutes. Let's do this one. It's nitrogen in the middle, surrounded on each side by 4 hydrogens, which again, 1 proton, first shell, 1 electron, there's a hydrogen. It wants to gain 1 more, okay? So I can see why all of these hydrogens want to share 1 electron. Now about the nitrogen, the central atom is usually a little bit one off, okay? And you learned nitrogen before in Bohr model. It applies here. You can do this stuff. 7 protons, 7 neutrons, 2 shells because it's row 2, 2 on the first shell, 5 on the second shell. And we know that it wants to gain 1, 2, 3 more electrons the first chance it gets, so it can have that stable octet, that magic stable number that Niels Bohr didn't even know about. Okay, so it wants to gain 3, but it looks like we've got 4 gaining over here, and some of these are temporary. Okay, by this one forming a, and this is like the juggling, that one ball that's up in the air that's coming back down, you're not really touching it, but it's there. That's what's going on with all of these. Okay, that's why I can kind of get 4 in there. Now with doing this, the first, it will actually lose 1 electron and get a +1 charge. Okay, what I'm going to want you to do is I'm going to give you that diagram. And then you're going to have a work area for the chemical formula, and you're going to count. You're just going to count. Oh, there's hydrogens. There's 4 of them, and there's nitrogen. And then I need a place for your final answer. Okay, your final answer. Oh, hey, yeah, I know this one, NH4. And then you're going to give me a name for it. Okay, and the name for this one is ammonium. Okay. All right. There's a sulfur. Let's have a sulfur in the middle. Double bonded on the top to oxygen. Double bonded on the bottom to oxygen. Single bond to oxygen on the side. Single bond to that side. I'm going to clean up this bottom one a little bit. Okay. We know each oxygen, 8 protons, 8 neutrons, 2 shells, 2 on the first, 6 on the second. It wants 2 more electrons, so the oxygen is going to bond twice. It's going to share 2 electrons and with the sulfur and pick up all the electrons it needs, so it has that stable octet. That's what it wants. Okay? So the oxygens that are just single bonded, they're not going to be quite content. That's why this SO4 group, I know you already recognize it, and the name is sulfate. Okay. When you look at a chart, you'll see that, oh, it's a -2 charge. This whole thing together can juggle by sharing these electrons between them and juggling that, and sometimes this one over here and this, sometimes this one is double bonded, sometimes this one's double bonded, and the top and the bottom ones are single bonded. Okay, they have that moving around, it's shifting around all the time, but by juggling they can gain 2 electrons. Okay, and hold 2 more, so it's got a charge of -2, and that's why we said these things were ions. Now remember, we said these polyatomic ions, they're like a group, they're like a team, they stay together. Okay, with these really strong covalent bonds, these strong shared electrons, they're not going anywhere. Most of the time this stays together. If you hit it with some really high heat or certain other chemicals, they will break up some, but usually the first choice is to stay together. Okay, and all this whole thing in negative charge, it's going to want to bond. A lot of times it'll bond to something with a positive charge, like any metal. Sodium atom, a sodium ion. A sodium will, I'll need 2 of these to balance out with at least 1 of those. But okay, again, you're going to give me just in a work area. You're going to give me, there's 4 oxygens, there's the sulfur, and there's no right way to do this. You're counting stuff up, okay? You might write it correctly the first time, that's fine. But then you get a chance to look at it for, oh, hey, my final answer, stuff that I know, the polyatomic ions I had to memorize. Oh, I know SO4, and its name is sulfate, okay? All right. Okay, here's the last example that I wanted to give you. Let's say we had something like Br double bonded to an oxygen, double bonded to an oxygen. Let me clean up the R a little bit. Single bonded to an oxygen, which oxygens don't like. Remember the oxygens that you know, 8 protons, 8 neutrons, 2 shells, 2 on the first, 6 on the second. It wants to gain 2 more. This one is going to be happy, this one is happy, this one is not, okay? By juggling electrons in between these, this polyatomic ion can gain 1 electron, okay? It will have a -1 charge. Again, this will always be given to you. This whole thing can gain 1 electron, -1 charge. You're going to have to take a look at this as I have sketched it. You're going to work area. You're going to say, oh, there's 3 oxygens. There's 1 bromine, 1 understood. So we don't put it, or you can in this work area. But then in your final thing that you give me, in the final response, it needs to be BrO3. And oh yeah, I know that one. That name is bromate because you did it before. Okay. Now one thing that I failed to mention, that just in closing, that all of these are attached to, let's say they're all attached to a hydrocarbon chain. They can replace one of those hydrogens. Okay. And here, if you remember from the other day, this is a chain of 4 carbon atoms, all single bonds, and the name is what? Butane. Good. Okay, we can substitute off one of these. Instead of a hydrogen here, we can stick this bromate group on here. Okay, and this oxygen is just single bonded. It's bonded to the Br. Oh, and then the other bond goes here. That's where it picks up its next bond. And it was already double bonded to those oxygens. So here is my bromate group that's substituted onto these. And all of these polyatomic ions, they can be substituted onto a group if necessary. So anyway, in OneNote, you're going to find a bunch of these polyatomic ions. And I want you to give me the work area. Okay. Again, this is identifying this, putting chemical formulas like BrO3. You've kind of got that memorized. Okay. I want you seeing this structural formula that goes with it. I want that more in your head. So this is just an exercise in you doing some of that. Thank you very much.